just want to discuss some basics about scientific notation. Numbers can go anywhere on a number line. You have 0, you can have 1, and then you can have 100, and you can have 1,000, and you just keep going on and up. And of course, it's not the scale, but numbers can be written. When numbers get big, it's sometimes nicer to write them in scientific notation, where we have a decimal place and just one number between 1 and 9 to the left of decimal. So, and then you could account for any number, both positive and negative, and you have a positive exponent. So let's say we have an example of, 86.72. In scientific notation, we just want to have one number, to the left of the decimal. So the decimal is right here. So we have got to move one place to that. So we have 8.672. Now it's going to be times 10 to some power. Well, move it one place, so the power is 1. Now the next question you always ask is the original number between 0 and 1? And if it's not, if it's more than 1, basically, getting back to the number line, it'll be a positive number. The only time we have a negative exponent for our scientific notation is when a number is between 0 and 1. Now it's difficult to comprehend because we have all these numbers in the number line, positive, negative numbers, but all the negative exponent numbers are only for this small space here. All the rest of them are for other numbers, going up to as high as you can count. So if we take a number like 0.0793, I want to convert that to scientific notation. Again, I only have one number, to the left of the decimal, and that would be right here. That'd be the 7. Well, in this case, we're moving 2 places, 1, 2. So we write 7.93 times 10. Now, you move the 2 places, you write a 2. And you ask yourself, is the number between 0 and 1? Well, yeah, this, 0.0793 is between 0 and 1 on the number line. So that will be then a negative number. Again, the only time you have a negative exponent is when the number is in this very small range. All the other exponents for the 10, or in scientific notation, are for any kind of number that's greater than 1. All right, so we'll do some examples for you. So some of you may have seen these before. Here's 6.4. I want to write it as scientific notation. Well, one number to the left of the decimal. All right, well, it's already there, so it's 6.4. Well, times 10 yet. Well, times what? Well, if I put a 1 here, well, multiplying 6.4 times 10, that would be 64. And we all know that any number to a 0 is a 1, so this is 6.4 times 1, which is just 6.4. Here's 85.2. Again, moving one place to the left. So it's 8.52 times 10. How many places do we move it? We move it 1. Is the number between 0 and 1? Well, 85 is more than 1, so it stays positive. That's the answer. Next one over here, 0.25. Decimal's here. It's got to go one place to that spot. So it's 2.5 times 10. Is this number between 0 and 1? Get on the number line. Here's your 0. Here's 1. Well, 0.25, yeah, it's in here. So this is definitely going to move one place. It's a 1. It's a negative number. Again, only between 0 and 1 are negative exponents. I'll try some other ones here. This 0.0095. 1, 2, 3 places, so it's 9.5 times 10. I moved it 1, 2, 3 places. Is the number between 0 and 1? Yeah, this is 0.095 between 0 and 1. It's a negative. I'll try a larger number, 630,000. Decimal's right here. 1, 2, 3, 4, 5 places. So 6.3 is the one number to the left, times 10 to the 5th power. Is this number between 0 and 1? Nope. That means it's positive exponent. Leave it like that. So those are the basics for doing scientific notation. Now we're going to write some scientific notation numbers in standard form, which means we get rid of the times 10 to the exponent. And this is pretty simple. Folks usually get too confused on these. So here's 5.2 times 10 to the 4, so I just write the 5 and the 2, and the decimal's here. Now again, this number is a positive, well, the exponent's of positive 4, so the number's got to be greater than 1, so if I move the decimal this way, I'm going less than 1. So I'm going to do the decimal to the right. I move it that many places, so it's right here because of the 5.2. So there's 1, 2, 3, 4. Put my zeros in there. And so decimal's here, so the answer's going to be 52,000. Definitely more than 1. A positive number. Let's try some other numbers here, or some other exponents. Here's number 20 here. 8.125. Again, I'll write 8.125. I'm not going to write the decimal there. I don't want to confuse myself, but I know it's here, and I have to go 6 places. Now this, again, this is a positive number, so I know it's more than 1, so I make this number bigger by going to the right. So it's 1, 2, 3, 4, 5, 6. Put the zeros for each jump. I now have 8,125,000, and that's that. Now let's try some negative exponents. Here's number 22. 4.7 times 10 to the negative 3. So I'll write the 4 and the 7, and the decimal's right here. It's a negative number, negative exponent. I know this number is going to be less than 1. So I'm going to start here and go 3 places to the left. 1, 2, 3 is my decimal. 0.047. It's between 0 and 1. That's my answer, 0.0047. Try one more that has some decimals or some other numbers with it. 71123. Again, I'll write the 7, 1, 1, 2, 3. Decimals right here. Again, 3 places. 1, 2, 3. So the zeros at it. That's the answer because of the negative number. It's between 0 and 1, and this number is definitely 0 and 1. If I'd gone to the right, to ignore the negative, it'd be 1, 2, 3. I'd have 7,112.3. Well, it's definitely more than 1. But that would not fit because it's a negative number. All right, good luck.